Hello, everyone, and welcome to today's webinar. We're allowing a minute or so for others to join, and we'll get started shortly. My name is Robin Carr, and I'll be your moderator for today's event. Thank you for being here, and give us just a few seconds. I can see the numbers are mounting. I'm going to give everybody just a moment, and then we'll get started with our planned presentation for today. All right, thank you once again for starting. Before we get started, I have a few housekeeping items to go over. If you lose audio or video, simply exit GoToWebinar and rejoin. That will resolve about 90% of all audio or video issues. In your menu, you'll see a chat feature that's available for you to ask general questions or ask for assistance if you're having any audio or video issues. You can also ask topic-specific questions by going to the question menu and entering your question there. Our speaker today is Blake Baca. Blake is the owner of BDB Solutions. Blake spent his first 20 years of his career at Alcoa. He is an asset manager with over 33 years of experience and a certified maintenance and reliability professional. Additionally, Blake is a Texas Tech alumni with a Bachelor of Science degree in mechanical engineering. All right, you're here for data collection, do's and don'ts. Blake, take it away.
Okay, hello everybody. Just want to go ahead and get started here. Robin had already gone through this. This is me, and she pretty much hit everything. The only piece there is I've had this consulting business since about 2009, and I did take a small stint, and I was the maintenance manager for Barrick Gold Corporation in Nevada for a couple of years. It was a client that wanted me to come on site and fill that role for a couple of years. So why are we here? We want to provide an understanding, really the purpose of data collection, what it will support, give you some guides and some things to, going forward. Data collection is not a super technical kind of a thing. So what I'm going to do is I'll spend a lot of time on the background of the why, and then we'll get to a point of saying, hey, this is the kind of things you need to do once you get down the road. So you'll see a lot of background. There's going to be some background on asset management, some things you may know about, some things you may not. And then we'll get into the data collection do's and don'ts at the end. Let's talk a little bit about asset management. So I believe, asset management is an ISO standard. So everything that we're trying to do is basically how do we purchase, how do we specify, how do we operate, maintain, and retire assets. And so everything we're doing from an asset management standpoint that includes even this data collection is cradle to grave with any asset. Why do we do it? I think a lot of our, depending on, there's a lot of people on this particular webinar, but a lot of times this becomes a maintenance thing. But the reason why we do asset management is we want to improve the reliability, which means that every time we want to push the button of the equipment, it runs. The availability, it runs for as long as we tell it to run until we tell it to stop. And of course, the bottom line is we're trying to get to a point we want to reduce costs. So we're either driving the cost per unit, whatever that would be, pieces or gallons or barrels or whatever we measure ourselves in, we want to drive that down. That's why we're doing asset management. Or we want to improve the uptime such that we can cover our costs with an additional amount of equipment. Additional amount of availability. So what's the foundation for all this? That's why we're doing data collection. So in order to have, we got to have an equipment register, okay? Inside of that equipment register is a master equipment list, okay? That's some of the things we talk about in there. Then we got to have a hierarchy. These are some things that I'm going to go through and talk about in this particular presentation as we go through data collection. Then you got to have the data in the system. The way I typically look at this thing is if we're looking at reliability, it's really a three-pronged approach. And the way I go about in this three-pronged approach is in the center, we have reliability. We have our work management processes that I'll just touch on a little bit. We have the bad actors, which are the things that are taking us down. And then how are we operating and maintaining our equipment, which is the asset strategies. So let's talk a little bit about work management. When I talk about work management, what exactly are we talking about there? Well, we're talking about the relationship between operations and maintenance. You know, how for sure we got to have that to ensure that how do we raise a work order, work request, and take that through the process from cradle to grave. We got to have a structure for processes and systems. And then we got to have, this is one of the biggest things, is that we have well-defined roles and responsibilities. So reliability in that case is identifying, you want to identify and eliminate the defects that result in failures and costs. And if we can't find that, then we want to plan, schedule, execute, and mitigate those things, thus improving the availability. This is a typical model that I use and work management. As you can see here, there's specific processes that we go through, and then we have a prioritization, meaning what is the urgency of when I need to do this work. So I think a lot of folks on this call are they're familiar with this, and this is a high-level process, but we build very detailed processes within each one of these. Once you do that and you have these processes built, you got to have a philosophy. So if you want to charge all your labor and materials to the proper work order, why do you want to do that? Because over time, depending on what your business is, you want to ensure that you're capturing the cost at the lowest level such that you can eliminate the defects or eliminate the failures or potentially postpone those failures. So you want to ensure that you're charging all your material. What are my costs at each one of those levels? So we want to make sure that we're mapping. So in a lot of facilities, and you guys may see some of this, we don't have a hierarchy that means, hey, we can't write it down to the motor associated with a particular pump or a component associated with that. So we want to be able to do that so we can capture those costs across our facility and for individual parts and whatnot, so we can see what type of cost. Because again, if you remember one of my first slides, one of the things we're looking at, we want to drive that cost down. We want to continually drive that cost down. What are some goals out of work management? Well, one of the issues that we run into is that us in the maintenance world, we're always talking about making sure that things follow a process, that we're planning and scheduling. And we typically will get in a situation where a lot of times leadership and operations, they don't see the value in that. They just want us to show up as maintenance people and we want to fix stuff every day. But we need leadership and operations to see the value in it. So how do we get them to see the value if we don't have a breakdown of how our costs are? So in order to do that, we got to be able to provide really good, efficient execution. So when we're working on particular things, we've got to make sure that we have everything we need to ensure that we're doing that and drive those things together. You kind of take a philosophy in a lot of our facilities, and most of our facilities, we're going through something that says, hey, we want zero injuries. Well, what we need to do is, just from a philosophy standpoint, we want to say, hey, we're going to get 100% availability. So as we use all the same processes and people understand the value and all the different things we do to move towards a zero injury culture, we need to have the same philosophy around reliability to move to 100% availability. Will we ever get 100% availability? We won't, because we have things that fail randomly and we have to put together. So we want to reduce that time as much as possible. We want to eliminate the mean time between failures such that it happens. And so getting all this data, getting this data collection allows us to do that. So that's really just a high level thing on work management. As you may or may not know, there's a lot of work that goes into work management, a lot of culture change. The piece I want to get into a little bit more here now is about the reliability engineering side of what we're doing. And that's the bad actors and the defect elimination and asset strategies. And this is just all these processes work together to build reliability in this three-pronged approach. So what are we talking about? We talk about reliability engineering, the two bottom areas. So we want to make sure that we're applying appropriate reliability methodologies. We want to make sure that we're focused in on condition-based, predictive, proactive maintenance tactics. And that's what reliability engineering works on. That's the world they work in. But the biggest thing is we got to make sure our reliability engineering group is working on the elimination of failures. Okay, they're not designing platforms. They're not managing the maintenance department. They're not teaching the planners how to plan work. They're eliminating failures. So how can these reliability engineers eliminate failures? The two ways that we typically want to go through that is there's two approaches. Okay, we want to use both of those. So let's talk about the first one, where we use root cause analysis. So that's where we use root cause analysis to understand that we want to find an unplanned event or an unwanted event. Okay, that falls into the bad actor defect elimination. Okay, we'll get into the asset strategies here in a minute, but looking at root cause analysis, think about root cause analysis and things failing. How am I going to know? How am I going to follow this? You're probably wondering, how does that apply to data collection? Well, I'm going to show you how that applies. Okay, so in bad actors or defect elimination, we've got this work management process. We've got people who are should be writing their work requests to a certain level in an equipment hierarchy. And we're trying to understand what the cost, the labor, materials, and the production downtime associated with a particular component is. All right. So through that process, we got to make sure that we're writing our work orders and we're capturing that data. Well, how do we do that unless we have a very detailed data collection process? We'll continue to go through that. Because what we want to do is we want to go through and have a Pareto analysis. Okay. Once we have the Pareto analysis, meaning I have certain assets that have certain costs charged to them, and I can write my work order to a certain level. I have data in the system that allows me to take a look at that, and I can go through and I can present that to leadership, and I can, as a reliability engineer or reliability engineering person, I can say, these are the things that are taking us down. Where would you like me to focus my efforts on making the biggest impact to cash flow? Okay, so you ask yourself when you're going through that, do I have a way that I can break my assets down so that I know what my failures are? I can identify them through the CMMS, and can I present that to leadership so that they can understand where are the things that are taking me down, or where's my highest cost, or what's making the biggest impact to cash flow? You got to have people. They don't necessarily have to have an engineering degree, but they got to have people who understand how to use the CMMS, how to facilitate root cause, and are they focused in on eliminating the failures? Obviously, no one in the facility wants failures, but we need people that's their job. Are they focused in on that? And are they trained on formal root cause analysis? So it's not 5 whys. There's PROACT, there's Apollo, there's Think Reliability. There's a lot of things that they're just more detailed and more structured approaches to root cause analysis. Okay, so when you go through and do that, and they're looking at root cause analysis, they end up coming back to what are the corrective actions that can help us in this particular thing. So again, how does this apply to data collection do's and don'ts? We got to have the data in order to do this. So how do you get the data? This is an example of what I'm talking about. If we're writing work orders to the correct level in the hierarchy, because we have an hierarchy and we understand what's happening in each one of those areas, well, we can Pareto out what are the things that are taking us down. As an example, what is our highest cost failures? And then down at the bottom example is where are our biggest, where's the most frequency of failures that are making the biggest impact to cash flow. So if you have something like this, you can present this to leadership. If you have the right data in the system, you can't get this data out if you don't have the right data and you haven't gone through a proper data collection process in order to create this level of data to know how much cost on a particular asset is happening and how many times it's failing. Okay, so this is an example of what a reliability engineer, based on good data collection initially, would end up having to present to leadership such that you could do root cause analysis and defect elimination, bad actor review. Okay, so now we can get into the other side of what that is, of the reliability engineering side of my 3-pronged approach here. Get into asset strategies. Okay, so what are asset strategies? Do you have them? So the kind of things, when I talk asset strategies, I'm talking about, do we have preventive maintenance procedures? Do we have condition-based things that we're doing? Are there run-to-failure scenarios or no scheduled maintenance? No scheduled maintenance is really just a better, more positive way to say run-to-failure. And how are those strategies created? Where did they come from? Did they come from OEM recommendations, which are typically pretty good, but everybody needs to remember that how do OEMs make their money? Do they make their money on selling equipment, parts, and service? So they have good stuff. And what I mean by that is typically you have a lot of assets out there and you have a lot of spare parts. Well, if your asset, you push the button, it runs forever. how much money is the vendor going to be making on that? All right, meaning he's not selling you parts, he's not selling you service. So OEM, I'm not down talking the OEM recommendations, they're good, but typically they're trying to sell you parts and service, and that's my personal philosophy on some of that. How else were they created? Were they created based on failures that we've seen, failure modes and effects analysis? Are there best practices? There are certain best practices out there for rotating equipment, for fixed equipment, excuse me, for electrical equipment. Sometimes we have PMs out there that are not value added because they are created because someone got upset because something failed. I have examples in my career where we were inspecting things because of an incident. We didn't get the root cause. They're not value added PMs. When you're building these PMs and these asset strategies, understand they need to be something that prevents a failure, okay, or substantially postpones it. Or were they created the right way, which is through reliability-centered maintenance, okay? Oops, hold on. If you have PMs out there existing, have those strategies been optimized through PM optimization? So there's a process that says, hey, are we looking at these PMs? Do they substantially postpone a failure? Do we have the right people working on it? Is there a better way to do it? Can we do some condition-based maintenance, things like that? Because if you go out there and you go to a typical facility, doesn't matter if it's a mine, a plant, in whatever industry, what I typically find when I go out there is they have some asset strategies, but most of them are, what you'll see over here on the left is you'll see that there's some condition-based, there's some vibration analysis going on, some analysis going on. You have some OEM type of things that have come in, but a lot of the times there's nothing going on. So the drive is by doing this, and again, you got to have the right data in the system. Get back to data collection here in a second. I'm showing you the background of why you need good data collection. Is you want to drive in the direction that says, hey, I have more condition-based. Not everything can be condition-based. I want to drive down my preventive maintenance because typically preventive maintenance is done during downtime situations. So we want to keep the thing running. And then some things we want to get to no scheduled maintenance, which is these things they're like a maintenance-free battery. They run forever. So we're trying to drive from the left to the right, and how do we develop these asset strategies? And the way we do that is through RCM. So RCM is different from root cause failure analysis in the fact we're trying to come up with what is a failure, and in the RCM case, a failure is the inability of an asset to perform the way you want it to perform. So I'm sure you probably have seen this quite frequently, the P to F curve, but what we're talking about here in showing this is, what is a failure? Well, a failure, when you're talking about it's not performing like you want it to function, is it starts to slide down this curve, all right? And by sliding down this curve, it's saying as soon as I move from a P2 to a P3, that's a failure. So when we're trying to address failures, we're trying to back ourselves up to the left on this curve and develop an asset strategy that allows us to continue to move to the left of this curve. So if we keep letting it go and we look at what happens, we can start out doing some condition-based things, and as we move down the curve, we're going to end up getting to a point where we come to a failure, which a lot of people consider a failure when the thing's just not running at all. But we had opportunity before that. So again, I'm going to tie this back into data collection and why you get to have this, but I'm just trying to give you the background of why we need this thing, because we want to keep moving to the left of this curve. Asset strategies, when I'm talking about them, just to be very practical, these are the type of asset strategies we're talking about. No scheduled maintenance. We don't replace windows. We don't do PMs on windows. We just, if they get broken, replace them. Headlights the same way. There's things that go on in an engine that we want to do. We're checking the oil. So that's a little bit more usage-based and condition-based. Same thing on brakes, okay? Condition monitoring or condition-based, and looking at the windshield wipers. When we change them, we start to see that they're cracking or getting like that. Same thing on tires. We're measuring the depth of those kind of things. Failure finding, we're checking the exhaust. Is it, is it too smoky? Things like this. So these kind of things are things that relate to asset strategies. And then we have the spare situation. So why don't we have 4 spares on a vehicle? Because over time we've decided one's enough, but because we can't predict these failures, right? So, but if you're going to go on a long trip and you have nowhere to go and the conditions say there's nowhere to pull over, maybe you're going to end up having 4 spares. But these are kind of things we're talking about. I'm just trying to give some examples of the asset strategies that I'm talking about. I talked a little bit about PM optimization. You have PMs. You're going to take these PMs existing. You're not going to start from scratch. And you're going to review these things. And you're going to look, when I do PM optimization, I'm looking for certain words. If it says sample or inspect, what are the details associated with that? Does this PM itself, does it substantially postpone or eliminate a failure? Okay, so this is part of the PM optimization process. And what we do is we revise those, and we make sure, again, we're trying to drive the cost down and keep our equipment running so that we don't shut it down unnecessarily, but we're also doing things that prevent failures and not just emotional type things. Because again, we're trying to back up this curve that I was talking about. Just something a little bit more on this curve is as we slide down the curve and you do this over time, we've learned over the years that the cost goes up. You know, you're going to have higher cost associated over time with more failures. So just something to remember. So as we get into RCM, now we're going to get into a little bit of the data collection. So how does this data collection, that this whole presentation, this whole webinar is about, why are you talking about RCM? Like that's reliability. Well, the reason is because we got to start out. Many places, I'm on a project right now where we don't have a master equipment list because no one's gone through and done it. And inside an existing facility, we don't have any data. We can go to the work order system, you know, CMMS, we can go look up a part or an asset, and it has no information, right? So operators out in the field, when they write a work request, when something's going on, they're writing it to the plant level, all right? So we've got to have a master equipment list. You got to create that master equipment list in order to get to the bottom where we're going to create this asset strategy. So that's how this ties in. And then you got to define a hierarchy, okay? So if you're defining, what's the hierarchy? So if I have a pump, do I just write the work order to the pump, or what if I'm having motor failures, or I'm having gearbox failures, or I'm having, you know, pump wear or something? What we're trying to do is figure out in this case what is the right level that we want to write this we want to create in the data in the master equipment list as far as hierarchy goes. And typically we're looking at, we got the facility, we have a section, equipment class, and we want to be writing our work orders and creating our hierarchy down to the component or maintainable item. After that, we have parts. That's really more of a bill of materials thing. We'll talk about that a little bit. But this is really an ISO standard that we use. And this is part of this data collection process. How do we create this hierarchy? Once we've got the hierarchy, then we want to do our equipment criticality analysis. Okay, so what is a process of determining what is our most critical asset so that we spend our time creating these asset strategies I talked about? We spend our time, our reliability engineering time, and also our operating and maintenance time to develop these asset strategies based on the criticality assessment. And these criticality assessments are, I'll show here in a minute, they go through and they force rank these things based on a common failure or a most frequent failure. So what we do is identify the most common failure. What are the failures? How does that impact the business? But we got to have that, again, we got to start with our assets. So we got to have good data. So in some cases, we don't have any data in our CMMS. So we got to go through and we got to go to a P&ID. We got to fill this thing out. So getting good data initially is good. And what we end up having as a result of that is we end up with a criticality. But again, to get back to how do I go about doing this if I don't have good data in my system is the issue. Once we get into that, then we need to break the equipment down into components. So if I have a pump, I want to break this down to my hierarchy. I want to say, okay, I got to break this thing down into the pump, gearbox, motor, and I need to do my failure modes and effects analysis on those. So how do each one of those things fail, and how do I prevent those? So if you don't have the hierarchy built into your CMMS, how are you going to go about doing that? It's a lot of work to get there. Once we get there, this is the part I was talking about. Once we're in this piece of looking through the failure modes and effects analysis, we're looking at this is the big part of the RCM and how do we eliminate that? We got to have this in our system to be able to do that. Then we're going to get to the asset strategy. What are the strategies we have to eliminate or substantially postpone those failures? And those are preventive and condition-based and things like that. So once we have all this in the system, right, and we create our asset strategies, how do we effectively enable ourselves to capture history and cost to effectively manage the assets? Okay, well, we said we got to have an equipment list. We started out with that. Okay, so what's the purpose? We want a facility where we have agreed to designs, processes, and guidelines for building that. So what is it? So you start out and say, okay, what level are we going to build this hierarchy at that we're going to do in the facility? And you got to have that master equipment list. And then after that, you got to have the master data. So what is that? Okay, we want to provide a documented, so this is a way to provide a documented starting point for continuous improvement. So once we have all this, we say we have our hierarchy, we have it built the way we want it, we have the data associated with each one of those, what are the specifications for the pump, the motor, the gearbox, so on and so forth. That gives us a way to start looking at where are failures happening and what are the costs associated with that. Okay. So what you got to get into is, when you're doing that, is utilizing those processes, utilizing that hierarchy. What's a location? What's an equipment record? Like I was talking about before, is it a component? Is it a spare part? So on and so forth. And you want to get to the lowest level that you're defining it such that you can write those work orders to the lowest level that meets the things that you need to do from a business standpoint. You need to be able to create that and have that. That way, the reliability engineer can do what he needs to do. So he's not having to go through and find things like keywords and work orders and things like this. If we have failure codes and we know what level we're writing the work order to, and we have all that data built into your CMMS, then the reliability engineer can do a better job at figuring out what the issues are. And that's what I was saying here. The other thing is, when you go through that, is how are you going to describe how you're doing things inside of that. You're going to have some noun qualifiers, things like this in there. And this is another example of the hierarchy, and we want to be down in the component and maintainable item area. Okay, so I kind of just gave you a fire hose approach to a lot of asset management, trying to get you to the end here that talks a little bit about what are the do's and don'ts. The bottom line is, too much data in your system is not enough, right? You want to put in as much data as possible. It's not having enough data is a bigger issue. Okay. So the first thing you want to do is, I've talked about a little bit, is establish that standard for hierarchy in a parent-child relationship, meaning taking that little pyramid, that triangle, and say, I want to be at the lowest maintainable level. So an example is, I was talking before, I said, break it down into a pump, for example. Are we going to break it down into motor, gearbox, coupling, and pump? Or are you just going to say pump when you're breaking down your hierarchy? Okay, so establish something and be consistent about it. Ensure all those things are linked. Go through and establish the hierarchy order the same. Okay, so like I said, if it's like the first thing is pump skid, and then it's pump, and then below that is your motor, your gearbox. Make sure that you can do that, and it looks like a tree. Okay, you could start with, really you want to start up at plant, and then you want to go to area, location, so on and so forth. But make sure that when you're doing that you have a consistent way of doing that. And then once you have that hierarchy broken down, make sure that you're having a good noun descriptor identifier asset number. So for example, you want to say pump, centrifugal, Goulds, and then some kind of, make sure that you're consistent on that, because that will allow you in your CMMS to find things that you need. Some more do's, again, you got to determine what level that is. I mean, I always recommend that we go to level 8, but depending on the size of your facility, you may want to go down, above that. But typically, the level 8, which is the component level, is the level that's best from a reliability engineering and capturing cost and eliminating failure standpoint. Okay. talked about it way in the beginning. I said, hey, understand the difference between the hierarchy and a bill of materials. So an example is if you have something that's again, looking at the pump, just going to continue as a pump example. Bill of materials may be something like pump housing, pump impeller, the coupling. You can decide, depending on the size, whether or not that ends up being something that's either a part of the bill of materials or an actual component you want to track. Bolts, nuts, things like that are obviously bill of materials. But it takes a lot of work to do this. That's why typically you don't see people doing this, because it takes a lot of labor and a lot of effort to do that. But depending on your business, it allows. That's why I was giving that background. If you have that level of detail, it allows you to drive continuous improvement. When you're writing work orders and things at the higher level in the hierarchy, at the plant level, at the area level, at the unit level, you just can't get into the details. You waste a lot of time trying to find out what your issues are and having the data to eliminate failures. Couple more do's. If you don't have any of that, these plants, these facilities were built utilizing P&IDs or process flow diagrams. You can build a pretty decent hierarchy just by following a P&ID, going through. And typically, I actually have a couple of individuals doing this right now for a plant that's actually being built. So we're taking the P&IDs, we're doing what I call a virtual walk down. So they're just following the flow through this as they come to a component. These guys are ex-planners. What they'll do is they'll go through, they'll come to something, they'll say, okay, this is a centrifugal pump. So they break it down like I've been going through. We capture all the data, right? We go into the engineering system and we capture the information, like for a pump. What's the motor size? What's the horsepower? What's anything that we can need from a maintenance standpoint? We're actually capturing that. We're doing it, I say virtually, because the plant hasn't even been built yet. So we're going through and capturing all that information and putting it into an upload sheet so that it can end up being in this CMMS. Got to verify it, right? So the best way you can do is if you do have an existing plant, is take that P&ID, walk it down, verify that's what you have on the drawing, see if that's what you have. If you have something in your existing CMMS, or just make sure that it's what it is, because it's going to be used in the future. That's what I was talking about before. Collect all those asset class attributes. So if you're thinking about this, you can think about how much labor and time it takes. And probably if you're in a place that has a CMMS that doesn't have a lot of data, it's because either someone didn't know that it was going to take a lot of time, or they knew that it was just something that maybe wasn't something they wanted to pay for at the time. But I tend to see it a lot that these CMMSs do not have hardly any data in there for anybody to do any continuous improvement. When you do that, when you're collecting this data, do a three-way match. Take the P&ID, like I was saying, check it to the field tag, what's in the CMMS, what's in your engineering file. Go through and make sure that what you have in your CMMS is exactly what you have on the drawings. And one or the other may need to be updated. You may need to get with drafting so they can modify the P&ID to match your CMMS, right? And so sometimes that even takes a little bit of, been in locations where it takes a little bit of negotiation to get that done. But you're trying to verify a minimum three-way match. So if everyone understands the value, which is the first part of what I was trying to give in this presentation, then we understand why we want to make the investment to make sure that we're capturing this data. And then assign each asset an asset class. So an asset class would be a certain type of equipment. Are we talking about, are we talking about rotating equipment? Are we talking about fixed? Are we talking about, and you can even take that a level down. If you're going down, you're walking down with the P&ID and you're just following the flow. One of the good things that you can do that helps with good data collection and also good from a future standpoint is we tag the assets with the correct asset number. So if you're looking at the P&ID, P&ID typically has a tag. If it doesn't, you need to create a tag. Tag being some kind of an asset number. Then we want to tag it in the field so that we can find these things in the field and we send a technician or a craftsman out there to do work. So we want to make sure that we've got all our boxes checked. We said our P&ID is correct. We have a tag in the field so that we can find it, In some places, they're even using RFID tags so that they can go through and they can, take the tag number with a gun, and that they know exactly that they got the right tag number. It's in the system, so on and so forth. But you want to make sure, at least from a manual standpoint, that everything is matching up and you make it as simple to find those things. Because again, we talk about work management. Why we're doing this, we're trying to improve the cost. We're trying to improve the productivity of the workforce. We're trying to reduce the downtime so that when we go out there and work on a piece of equipment, we know exactly wasting time trying to find it. We're there, we execute the work. The work's already been planned, scheduled, executed. That's how these three-pronged approach I was showing you guys. That's how that all fits in together. Okay. Another do is you can have all this stuff, but you got to make sure that it's mapped correctly in accounting so that all of the data and all of the information, the cost data, the materials and labor is going to that particular work order that rolls up to the asset, that rolls up to the GL account or the accounting system, so that you can provide the right information to your leadership about what kind of money you're spending, what opportunities you need to invest more capital and things like that. Make sure that that's an issue. So you got to have accounting involved in some of this as well. Okay, let's get into some of the don'ts. Some of the don'ts that you want to do when you're getting to this point of getting data is just don't assume that your CMMS is correct. And probably nobody does that, but sometimes people outside of maintenance who are operations and leadership, they may not make that assumption and may be new to the facility. And your CMMS is not correct, right? You haven't gone through all this detailed data collection process to do that. So, but don't ever assume what's in there is correct. Don't put the minimum amount of data in. That typically happens due to resource constraints, things like, and then, oh, we're going to build it as we go. So we're going to create bill of materials. We're going to create an asset. We put in pump, and we just put one asset tag in there. Don't think you're going to do this as you go, okay? It's going to be something that you're going to have a campaign to do it. It's like, hey, we understand the business case. Business case is all that information I gave in the beginning of this presentation. And we want to be able to capture data for continuous improvement. Go through, pick an area, go through that. That's why you want to do this criticality analysis. Where do I want to spend my time doing this? Okay. And then actually go through and create that whole process. Get that data. Think you're going to build it as you go. You're never going to have the time because, as you well know, everybody that works in a facility, there's always going to be something else coming up. This is a huge one. Don't assume the IT department can take some simple spreadsheet that you give them and put the information in the CMMS. Now, eMate, which is part of Fluke, they can give you a spreadsheet that you can populate, and it tells you exactly what you need to populate so that it can be uploaded. But the IT department, they're not going to be able to give you that. That's not very typical. Don't think that they have that, right? They're not going to have anything like that. But again, eMate has something like that. Fluke has something like that that they can give you. You can walk the system down. You can take the P&ID. Again, it takes a lot of time and effort to do it and get things like, the motor, the horsepower, the RPM, frame size, voltage, et cetera, et cetera. Big thing in this, I see this a lot. Don't forget to check for duplicates, duplicate tags, duplicate asset descriptions, things like that. That's something you need to make sure of when you're doing some. Don't forget to check for those kind of things because you can find a lot of duplicates in there that will cause you problems when your groups are trying to work on this stuff once you've got all your data in the system. That's pretty much it for now. I know there was a lot of background information on, why you do this, and it was, I crammed a lot of information about work management and defect elimination and asset strategies into the beginning of this presentation. But data collection is pretty straightforward. It's a matter of walking down the equipment and getting the necessary data you need to ensure that your technicians and your reliability engineers have the right information for continuous improvement. What is that continuous improvement? Well, that was the first part of this presentation, and that's what I wanted to give. So that's all I have. If there's any questions or anything, I can field some.
It would help if I took myself off mute. Blake, there are actually several questions that came in while you were talking, and then people would respond that it had been answered. But there are a few questions that are still remaining. One question was the spreadsheet that you shared. How can someone get a copy of the spreadsheet or possibly even the presentation you shared?
Are you talking about the spreadsheet that was the, you probably can answer this, but I'm assuming it's the spreadsheet that was a criticality analysis?
Correct.
I can, well, that spreadsheet, I'd have to show you how to use it. I can't just send it to you. I have to show you how to use it. Because
All right.
there is some of our intellectual property in there.
All right. So if someone has questions, they can just reach out to you at info then.
Yes, for sure.
All right. And then another, oh, go ahead. I apologize. I didn't mean to cut you off.
We can talk about how we go about doing that. It is part of our intellectual property, so I couldn't just send it to you. I could send you this presentation. That's not a problem. Whoever that is, I can send that.
All right. And then a question that came in early was, what factors are adding to the cost of a failure?
So we have labor, materials, and then the cost associated with downtime. So I've had an impact to cash flow. I've lost this much production, or the opportunity is, if I was running, I would have had this much production. Depends on the situation. You know, everybody's going to be different. Those basically are the three factors. Labor, so that would be maintenance labor. That would be any maintenance materials, and then any loss in production that you would have, or any opportunity for production that you would have had you not had the failure. Those are the factors go into cost.
All right. And I believe, other than many things put in the question section that said this was a great presentation, I want to review in the recording. I've got a couple saying, what a great class, well done. So thank you so much, Blake. We had many participants today, great feedback from those participants. For those that joined us today, thank you for joining us. Blake will have another webinar coming up in a few weeks. Please look for that. And when we close the webinar, there will be a brief survey that will pop up. Seriously, 3 questions. Please answer the survey. It helps us to give you presentations like this that give you a lot of benefit in a little bit of time. Blake, thank you again for joining us today. We appreciate the time and effort that you put into helping us all to do better at what we do.
All right, thanks a lot. Have a good one.
Thank you all. Have a good day. Bye.
Bye-bye.